Okay, we want to find the prime factorization of 84. Okay, we're going to use the prime factor tree. Okay, so the first thing we do is find the smallest prime number that goes into 84, and that is 2. How many times does it go into 84? 42 times. Now we say, what is the smallest prime number that goes into 42? Smallest prime number that goes into 42 again is 2, because that's even. 2 times 21 gives us 42. This time though, 21 isn't even, so 2, which is the smallest prime number, doesn't go into that, so we're going to look for the next smallest prime number, and that is 3. And 3 times 7 is 21, and in fact 7 here is a prime number, so that ends our process. So we can write 84 is equal to 2 times 2 times 3 times 7. 2 times 2 times 3 times 7. And if we just look what this means, this says 2 times 2 times 3 times 7 does equal 84. These are all the factors, the prime factors, these are all prime numbers that multiplied together equal 84. So 84 can be written as the product, that's the multiplication there, the product of its primes. This could be simplified. 2 times 2 could be written as 2 squared times 3 times 7. Let's do another example. Let's find the prime factors of 120. Okay, so if you're going to use this video, you might decide to pause it, have a go yourself, and then see if you get the same answers as I do. Okay, welcome back. Okay, let's do the prime factor tree for 120. What's the smallest prime number that goes into 120? Correct, it's 2. 120 is even. This is a nice easy one. 2 times 60 is 120. And again, the smallest prime number that goes into 60 is 2. 2 times 30. Oh, this is really easy. 2 times 15. 15 is a prime. We can easily see that 3 goes into that, and in fact 3 times 5, and they're both prime numbers, so that ends our search. 120 can now be written as 2 times 2 times 2 times 3 times 5. 2 times 2 times 2 times 3 times 5, which again could nicely be written as, that's 2 cubed, isn't it? 2 cubed times 3 times 5. Actually, let's just have a look at this. 120. How useful is this this prime factorization that we've got here? I mean, for example, this is 2 times 2 times 2, which is 8, and that's 3 times 5, which is 15. 120 is 8 times 15. Or we could have said 120 is equal to 2 times 5. And what have we got left? 12. Or we could see that 3 times 2 is 6. And so that's 6 there. So we're left with 5 times 2 is 10 times 2 is 20. So we can in fact use prime factorization to find all the factors of 120. We'll come to the uses of prime factorization in the next lesson. Okay, let's do one final example. Find the prime factors. Actually, no, I'm going to rewrite that. Let's rewrite that one. Right. 2310 as the product of its prime factors. Okay, so just made that a little bit more formal. So what does the question say? So let's say you had this question on a test. It says write that number as the product, that's multiplication, of factors, so the factors that make 2310, but those factors must also be prime. Okay, this is quite a large number. Okay, we can see that it's even, so we can see that 2 is going to be the smallest prime number that goes into that. How many times does 2 go into that? It goes into that many times, 1155. Now 1155 isn't even, so we're not looking for the number 2. Now we want to see maybe if 3 goes into 1155. We can do a test, a divisibility test for that. Let me just write it here, 1155, and if you notice, 5 plus 5 is 10, plus the 2 there is 12. 12 is divisible by 3, and therefore 3 will be a factor of 1155. So 3 is the next smallest prime number, and that goes into it 385 times. Does 3 go into 385? 3 plus 8 is 11, plus 5 is 16. 16 is not divisible by 3, so therefore 3 isn't a factor. But we can see that 5 is. Because it ends in 5, and that gives 5 times 77. Hopefully we can see that 7 is the smallest prime number that goes into 77, and 7 times 11 is in fact 77, and therefore we can write 2310 as the product of its prime factors, and it is 2 times 3 times 5 times 7 times 11.